Okay, so let's evaluate the integral from 0 to pi thirds of 7 plus sine theta divided by cosine squared theta d theta. Now taking a look at this, we'll notice that it's not a standard integral. We can't really use any u substitution, so we're going to see if we can do some trig identities. So first, let's take a look at the integrand, which is 7 plus sine theta divided by cosine squared theta. Now if we look at this, we can see we can break it up into 7 over cosine squared theta plus sine theta over cosine squared theta. And from here we can apply some trig identities. 7 over cosine squared theta is equal to 7 secant squared theta. And sine theta over cosine squared theta is equal to secant theta times tangent theta. And that's because this guy here, let me just focusing on this, we've got 1 over cosine theta times sine theta over cosine theta. So that's where we're getting the secant and the tangent from. So as a result, you can see that the integral from 0 to pi thirds of 7 plus sine theta over cosine squared theta d theta is equal to the integral from 0 to pi thirds of 7 secant squared theta plus secant theta tangent theta d theta. And what we can do from here is break this into two integrals, and these two integrals will become standard integrals we can solve. So this is equal to, I'll pull the 7 out, this 7 times the integral from 0 to pi thirds of secant squared theta d theta plus the integral from 0 to pi thirds of secant theta tangent theta d theta, which will be equal to 7 times tangent theta evaluated from 0 to pi thirds plus secant theta evaluated from 0 to pi thirds. Now, evaluating these, you can use a unit circle if you want. What we're going to get is 7 times tangent pi thirds minus tangent of 0 plus secant of pi thirds minus secant of 0. Now this will equal, where my cursor go? This is equal to 7 times tangent of pi thirds is root 3, tangent of 0 is 0, secant of pi thirds is 2, and secant of 0 is 1. So our final solution will be 7 root 3 plus 1.